Hi Piyush, will we wait for more time?
Hello? Yes, yes. So we can wait for till 9:10. Yeah.
Hello. Good morning, all. Am I audible, right?
Good morning, Pradeep. Yes, you're audible.
Yeah. So today we'll discuss about the 12.2. Okay. So let me share my screen. So we already discussed about the 12.1. This is the continuation of that. So in the 12.2, my voice is clear, right? Hello.
Yes,
Yes,
it's clear.
Okay. So today we'll discuss about the introduction of the query optimization. Then this 12.2 is mainly focused on the relational expression. So we see how the transformation of the relational expression. Okay. So first we will see introduction about the query optimization. So
I just have a question from yesterday's session. Actually, it didn't strike at that time. Can I ask now or after you complete?
yeah.
So yesterday when we were learning about the initial part of join, when the records were supposed to be joined and we were going through the disk structure, how that movement happens. My question is why it does not complete R1 and R2 at the same time when the other block is present. Why does it just do only for R1 AB and it moves, then it does for CD and it comes back? Why the records R1 and R2 are not joined when the block is present over there?
So we are talking about nested loop join, right?
Nested loops joined, right?
Okay, so after that 12.2, I will discuss. Is
Okay,
that
fine.
okay?
Fine, sure.
Okay. So in the query optimization, we will consider throughout this example. So this is the relational. We consider this relation, right? So first we consider the course. So course involves the course ID, titles, and the department, and the credit, and the instructor ID, names, department name, and the salary, and it is connected with this. This is the relation teachers. So teachers contains the ID of the instructor and the course ID, section ID, semester, and the year. So throughout this slide, we will consider this particular example. Okay. So here you can see the alternative ways of evaluating the given query. So first we can, this is the expression of the particular queries. The query is the find the name of the instructor of the music department, and they teach the course name they teach, right? This is the question. So this is the answer. So this answer of that question is written like this two way. So what is the SQL query? So right. The question is, let me write. Find out the okay. Name of the courses. So okay, I forgot. So this is the find out the name of the instructor from music department. Okay. And the name of the courses they teach. So can anyone tell me what is the SQL query for that? You got question, right? Find out the name of the instructor from music department. Okay. And the name of the courses they teach. So SQL query is like, you can convert this expression also. So this is the projection operation you already know about. This is the projection operation. This is the selection operation, and these are the natural join. Okay. So select name, title from. So this is the present in the bottom level. So first we will join natural join between these two, then this one. Okay. So courses, course, natural join, teaches, then natural join, instructor. Okay. And in the from condition, we put this condition, right? Okay. So this is the first, this is the SQL query. Then since the parser or the in the query optimization, the parser and the translator part, we convert it into the relational algebra, or sometimes we convert it into the expression tree. It is the based upon the design of the DBMS. Okay. So this is the expression SQL query. Now, if we convert this thing into the relational algebra, and we got this thing, and this is the, this particular diagram is called the expression tree. So let me remove this thing. And there is also other way to write the similar query. So same problem we can write in a different way also. So here you can see, first we select the only instructor from the music department. Then here you can see the similar step, natural join between teaches and the course, and only the selected. So this is the, we performs the natural joins between the instructor tables, the whole data that is present in the instructor tables, we performs the natural join. But here you can see that in the instructor, we only filter out only the instructor of the music departments. Then we apply the natural join. So natural join is a natural join is a cost, means the operation involves a cost in the natural join. So by looking at these two, so suppose these are the writing the SQL query of the, so suppose two student writes the SQL query. One is like first student. So suppose this is a student one writing the solving problems in this way, and the student two solve the problems in this. So by looking at this, and I suppose I giving the condition that the natural join operation is a costly. Okay. So can you tell me which of the uh, SQL query is the optimized one? Hello. Am I clear? Right. So these are the two approach of writing the same SQL query. Okay. So which one of these is optimized one? So okay, let me give an example like this. So suppose this involves the 10 records, this is the 20, and this one is the 30. Okay, so suppose we performs the natural joins. So how many natural joins? So teachers have the 10 records and these have the 30. So total numbers of the natural join we have to perform. So that is, suppose assume that's the all the value are the present. So this is the numbers of the natural join we have performed. And is the here you can see the 20 records and all the matching are there. So similarly there is the 30. So okay, so instead of natural join you can this is not clear. So suppose this will take the cost is, you understand in this term. Okay, so suppose this is the numbers of the cost. Okay, this is the cost, and here you can see the cost is 20 into 30, that is the 6,000. But here you can see, suppose the in the total numbers of the 20 instructor, suppose the 5 is the 5 instructor from the music department. Okay, so then what is the cost? So 30, you can, so you can see the cost of this one is the much more some optimized one than this approach. But the both the query will return the same result, right? So what's the computer will prefer for so this one will prefer the computers. So this is not from the you as a student or as a client or as user, you unable to all time you unable to write the optimized query one. So this is the responsibility of the computer or the DBMS system to check with the uh, equivalent expression of this, and which is the more optimized one. Then it's consider that particular expression and evaluate in the uh, evaluation engine. Okay, so that is the responsibility of the DBMS. Okay, so up to this is clear. So now we see the next term, that is the evaluation plan. So an evaluation plan defines the exactly what algorithm is used for each operation and how the execution plan execution of the operation is the coordinate. So here you can see, the selection operation is performed in this particular one, select operation and the select operation. So when we performs the select operation or some operation is performed, so based upon some operation is happened in the backend. So how this operation is performs, so which algorithm is used for each operation, that is known as the evaluation plan. So here you can see in the instructor we can index the music departments. So we use the department name. So suppose the instructor is also indexed by the music. Okay, so department name, by the department name it is an index, right? So we can, by looking into that the which of the particular key is the music, right? So we can extract the data directly from there. And in the year, So all the year can have the different type of value. So we need to perform the linear scan because by the year we cannot index. So each value is a unique in the year. So then we perform the merge join. So this is in this particular natural join, we perform the merge join, right? So this, and here we perform the hash join. So this each operation here you can see the different type of algorithm is used. So that is known as evaluation plan. Okay. Then we will see the so next point is the cost difference between the evaluation plan for the execution query can be enormous. So here
Sir,
you can yeah, sure.
what is hash join and merge join?
So yeah, so hash join is during the join we perform there is the two different approach, two other approach also there. So but hash join you can see, so there is the large numbers of the set relation, right? Large numbers of the relation. So here you can see, suppose there is the two relation A and the B. Okay. And this particular A is consist of suppose 1000 record and B is a consist of the 3000 record. So what happens in the hash join, we see which of the particular relation has the less numbers of record. So this A have the less numbers of record. Then yeah, by using this the key of whichever suppose there is a condition in the natural join. So suppose the same numbers of the column here, the suppose I is the columns between the same. Using this we performs the join. So condition is where A dot I equal to B dot I. So here you can see A have the less numbers of means less numbers of record, and so using this key or this attribute of A, we creates a hash table, right? Using this key we create the hash table, right? You understand? So there you can see the 1000 hash table. I is the key and this is the record, right? In the hash table. Hash table,
Yeah.
hash is the hash table is used for the indexing, right? Hash
Yeah.
mapping you can, yeah. So after that you can perform the natural join with this. So this is the key is present of whichever the small numbers, then we performs the natural join. So suppose this is the I key, hence we performs the natural join. Okay.
Yeah.
And since the merge join is the simply we merge the whole data set. So here we do not any approach like this in the hash. So you can say the hash join is a much more efficient than the merge join.
Okay.
And the next point is the cost difference between the evaluation plans for a query can be enormous. Yeah, we already checked that. So there is the same query, but the if the approach is a difference. So yeah, we can see the cost of, you can say the cost of here is the 1500, but here 16,000. This is the approximately 4 times of this particular one. So that is the so cost difference between the evaluation plans for a SQL query can be in, yeah. Hello.
Why
Yeah.
we are taking instructor 5?
Which one? Where? Here. Hello.
Yes, second example, instructor में instructor
This
Why
one.
they are taking 5?
Oh, okay. So suppose this is the instructor. So here instructor present in the all the department, right? But here only we consider the
Yes.
music departments. So maybe equal to or less than that value. So I takes the 5 is the numbers of the instructor from the music departments. So this is the assumption. So you can take also 20 also. So that value is not greater than that, this value, right? Not greater than,
Yes.
always less than equal to, right? So anyhow we can, this is the always the optimized one when we compared with this. You got the idea, right? Hello.
Yes. Yes.
So that is the same point is so for example, suppose the difference may be in the second or day also sometimes. So now we will see the steps in the cost-based query optimization. So first we generate the logical equivalence extraction using the equivalence rule. So this we will see in the next slide onwards. Here, what is this? So first we generate the equivalent expression using this rule. So what are these rules? So we'll see. And then we annotate the resultant expression to get the alternative query plan. So which is the for with each equivalent expression we add some cost of the cost, assume some cost is there, right? So as we previously saw, and after that we will choose which is the cheapest one based upon some estimated cost, right? So the estimation of the plan of the uh, estimation of plan cost is based on the statistical information about the relation. So what are the, we consider what is the numbers of tuples, numbers of the distinct values for uh, an attribute. So this is the taken care by the database system management. Okay, this all things whichever is the optimized one. So we generally what we do, we only write the SQL query, and after that the database system management will take care of that. The optimized always it run in the backends, the optimized one of that. So second point is the statistic information, statistic estimation of intermediate result. So you can see here some intermediate result will generate, right? So here some intermediate result will generate. So after, based upon this also we choose the next algorithms for this operation. So by seeing the nature of the intermediate result, and whatever the we each operation is a in each operation there is some algorithms to evaluate that. So we also see which algorithm to choose, right? So that also need to be taken. Okay, so next we will see the transform okay. So next we will see the transformation of relational expression. So in this topic, so first is the we will equivalence. So when we say that two relational algebra is the equivalence. So two relational algebra expression are said to be equivalence if the two expression generates the same set of tuples on every legal database instance. So if we run the both the relational algebra expression on the relational tables, then it will always generate the same set of the tuples. So we already know that's the set operation, the relation, the DBMS or relational algebra is very much inspired from the set theory. So that's why the next point is the order of the tuples is irrelevant, right? So that's not consider. And the second point, we do not care of it. They generate a different result on the database that violates the integrity constraint. So if there is maybe we got the different condition, maybe possibles on the when we applies the same relation to equivalent relational algebra on the same database, so it may be sometimes maybe gets the different results. That is because of once that they violates the integrity constraint, right? So this equivalent is defined based upon the relational algebra expression. Similar things we can say for the in the SQL query. But in the SQL query, we consider the multi-set, right? So you can see in the SQL query, it's do not removes the duplicate value. It also allows the duplicate value in the SQL query. But in the relational algebra, it is not not allows the duplicate value, right? So that's why the different definition for the SQL one. So here you can see in the SQL, the inputs and outputs are the multi-set of the tuples. Okay, so two expression in the multi-set version of the relational algebra are said to be equivalent if two expression generate the same multi-set of tuples on every legal database instance, right? So same thing, only here is the we allows the duplicate value also. So how to find the equivalent? So by the equivalence rule we will find. So next we will see the equivalence rule one by one. So first one is the conjunctive selection operation, and the deconstructed into the sequence of individual one. So if any expression like this, select theta 1. So theta 1 is the one condition. Then conjunction means the in the sequel, it is the equivalent to the AND operation, right? Okay. And then second condition ends the expression. And we can write this thing in this way. Select. So what this means? Okay. So suppose there is a SQL query. Select. Okay. Let me take this one. So here you can see instructor tables ID, name, department name, and the salary. So let me write the first expression like select the name of the instructor from instructor, and the select means where we put the condition. Suppose theta 1 is the department is music, department name. So that is the department name is music. Okay. And this is the conjunctive operation, that is in the SQL, it is equivalent to AND operation. So department name equal to music, and so suppose salary is greater than 70,000. Okay. So we can write this similar expression in this way. select name from. So first, this is the theta condition, that is the, so suppose select or you can simply say select a star from instructor where salary is greater than 70,000. So we have to rename it as suppose DC, and where this is the theta to condition we put in the nested query, then where we can write the next condition, that is department name equal to music. Okay, you got the idea, right? So this both will return the same result. Okay, so that is the first equivalence rule. So anything that is the if that is the right like this, select theta and the conjunctive and theta 2 and expression, that can be, we can deconstruct this one, this condition one by one. Here you can see. Okay, the next one is the selection operation are the commutative. So that is the what this means, we can interchange this one. So here you can see select theta 1, then the select theta 2 in the expression, we can interchange this one. So first we can apply the theta 1, then theta 2, right? So here in the outer one we apply the theta 2, but inner one is first, this is the simply way, simply means here we first applies the theta 2 then theta 1, and here is the first we applies the theta 1 then theta 2, both will result the same, the result will be same. Okay, so the third is the only the last of the sequence of the projection operation is needed and other can be omitted. Here you can see in the expression, first suppose in this expression, first we return in the select statement as suppose ID, name and the seller, right? In the next L2, suppose ID and name is required. In the next L2, this is the L2, this is from the LN. Okay, and so L1 is the, we only needs the ID to do display. So we can simply write on this expression pi L1, right? That is the select ID from the whatever the expression, right? So this is simply, that means we can omit the inner part. Okay, okay. After the fourth condition is selection can be combined with the Cartesian product and the theta join. So here you can see you may be come across this particular expression. Suppose sometimes we are writing this like, okay, let me give this example. So sometimes you performs the cross product, then you apply some condition. So we can say that is the similar to the theta join. So what, okay, let me explain this one. So select, suppose you needs the instructor names and the year from the teachers. Okay, So select name and year from instructor. That is the basically the cross product. So teaches, where then we put the condition like this, the instructor, suppose this is the I and this is T. Okay, I dot id equal to T dot id, right? We apply this kind of condition. You already used this particular approach. Okay, so similar thing we can, so this is the same thing we can see in the relational algebra, that is the theta id and the instructor and the cross join teaches, right? This is the same thing. We can write this thing in like in another, so that is the theta join. So theta join is the, you can see, that is the, we put in the theta join, we put the condition on the natural join, we put condition, right? So theta join is this. Okay, so suppose you can say the inner join and on this particular one. So this is the same thing. So that is the equivalent to okay. So these two are the same thing. Okay. So here you can see this selects operation we can put here also. So you need to remember this thing, how we can replace this thing. So after that, the theta join, whichever the selection condition is outside of this operation, we can consider this operation inside the during the this theta join also by using conjunctive, right? So this is the another way of writing this particular query. So now we will see the theta join is the commutative. So it doesn't matter in which orders we are writing. We can first write, so in the inner join, in the from, here you can see I natural join J, or simply E1 natural join E2, or we can also say from E2 natural join E1. So both are same, it doesn't matter. Okay, so these are the commutative operations. So theta join can be, we can interchange this one, whichever first we can take E1s then E2, similar E2 or E1, it doesn't matter. Okay, so in the sixth first is the natural operation are the associative. Okay, we already seen that one. So first way we can perform the first natural joins between E1 and E2, then we perform the natural joins to E3, and we can also do the first natural join performs between the E2 and E3, then we perform the natural join with the E1. Okay, so these two are also same. So next point is theta joined are the associative in the following manner. So here you can see E1 theta join E2, then theta join with theta 2 and the theta 3 and E3. So here one condition is given, the theta 2 is involves from the expression E2 and E3. So this theta, so whatever's the based upon this uh, condition is a condition, or you can say the attribute is present in this two, of course. So in the other word, you can say that this condition, so suppose ID, so ID is involves in the instructor and the teachers only. So you can replace here, so that condition. So first we the similar thing, if theta 2 is present in E2 and E3, then we can independently perform first the theta join, that then we performs the this theta 1 and the theta 3 with the E1. Okay, so when you apply this thing in the SQL query, then you understand what is the difference. So yeah, so whatever we learned here, so there is the pictorial we can represent this thing in the pictorial way. So here you can see E1 theta E2, we can represent in the pictorial, we can represent this thing as the theta E1 and E2. So in the bottoms we writes the whatever's the expression, so this E1 and E2 are the expression, and then we in the connected with whatever's we operation we are performs, right? And we already know this theta, these operations, the theta join is the commutative, so we can write also we can replace this. So here you can see E2 theta and the E1, right? And this one is the associative one, so natural join are the associative. So yeah, so whichever the present in the bottoms, so in the bottom, right? So here you can see this is the present in the bottoms, then up there. So this simply means that we perform first this operation. Okay, first we performs E1 natural join E2. So this means first we performs this bottom operation. Okay, then we perform the E3 similar way, whichever's in the bottom line. So there's E3, so that perform first, and we can write in the any side. So E1, you can write also this side. So main things need to focus is the E2 and the E3 is performed first. Okay, so similar this 7a, what is the expression? Check. So okay, hello, am I audible? Okay, so before we discuss this one, okay, before we discuss this 7th A, first we need to check what is the rule. Okay, equivalence rule. So in the 7, the selection operation distribute over the theta join operation under the following two conditions. So what is the first condition? When all the attributes in the theta 0 involves only the attribute of one expression E1 being joined. So what this means, so this particular expression means whatever we condition applies, this is belongs to only this E1 expression, right? So this theta joint is in the theta joint, E2 is not involved. So we can replace this thing, or we can write this thing into the another way. So that is the first way performs the this theta 0 filter out based upon the theta 0 condition from the E1. Then we performs the theta joint with the E2. Okay. So and write in the pictorial way, or draw in the pictorial way in this way. So here you can see if theta is only has the attribute, theta means the condition, and that condition is from the E1. Suppose the instructor, this is the instructor and this is the teacher's table. Okay, so instructor table says that you can apply this thing as a condition like the salary is greater than 70,000. Okay, so you can say the first you can, this is the two types of approach may be possible. First, we apply the natural joins between E1 and E2. Then we applies the this salary is greater than 70,000. Okay, and you can also do that for the instructor. First, you filter out the instructor whoever from the, whose salary is greater than 70,000. Then you performs the natural joint with the E2. Okay, so simply this particular statement. And the next point is, once the theta 0 is involves only the attributes of E1s, and this theta 0 is involves only the attributes from the E2. So this simply means this expression here, this is the selection operation. Okay, selection operations theta 1s and theta 0, and E2 and E1s theta 0 and E2 theta join then E2. So what that means, simply we can represent that things also, or consider with the example. So this is a, you can say this thing is teaches. So let me take the E1 is the instructor and E2 is the suppose teaches. Okay, so you can simply write this thing like this. So from, you can write this expression from instructor or theta join, we simply put the condition. Inner join teaches on. So suppose this is a rename as the I and this is the T. So on I dot ID equal to T dot ID. So this is this part. Okay, and there the condition is where I dot salary is greater than 70,000 and T dot year equal to 2009. Okay. So this thing we can write in this way also. So okay, let me explain how it is. Okay. So this is the similar. So first we performs this one. This one, how to write? Select star from instructor, right? So select a star from instructor where salary is greater than 70,000. Okay. So suppose this is as I rename this whole expression as the I, or simply for understand we can say E1. Okay. Then whatever this expression returns, then we performs the natural this we can also apply the natural joins, but here the theta's inner, and we can write the similar expression for this one. So select from
Teacher.
hello, yeah, teachers where, and what is the condition? That is the year equal to 2009 as E2. Okay. So after that we have to apply this condition. This condition is remaining. Okay. So after that E2, then we can simply say on E1 ID equal to E2 ID. Okay, you got the idea how to write this whole expression in two different way.
Yes, sir.
Okay. Now the point 8 is the projection operation is distributed over the theta joint operation as the follow. So the first point is if theta involves only the attributes from the L1 union L2. So this L1 is the list of attributes that's present in the select operation. So instead you can simply say whatever L1. So now we will see the projection operation, and the previously all the examples involves the selection operation, right? So that things put in the where condition, and this is put in the select condition. Okay. So now see, and the point is if theta involves only the attribute from L1 union L2. Okay. So by selection, so here you can see by L1 union L2. So what this means? This means simply that operation that is like select. So some query is like this: select the name of the uh, instructor from the music departments, and or name of the instructor from the physics department, or both. So that query you can write like this. Okay. So this L1 means I don't think that is a good example. So okay, so you can understand like this. The expression E1 and E2, these are the two expressions. First we performs the theta joint, then the whatever's the attribute we need to project, right? So that is, we can say from the L1 union L2. So L1 union L2 means, okay, union operation, you means you know about the union operation, that the first, okay, let me write L1. So this from R1 and this is the L2. This is the performs the union operation. So you know the union for the performs the any set operation that need to be union compatibility. So you already know about the union compatibility method. So can anyone tell what is the union? What are the two conditions? That is the two conditions, right? For the union compatibility. First condition is, so let me check. So for the union compatibility means the order's attribute is present. Suppose the from the expression A, the attribute is A and B from E1 expression, right? A is the one attribute,
Yes.
B is the second attribute from the E1 expression. And suppose D and C and D is from the E2 expression, right? So first, the order each, the numbers of, first thing is the numbers of attributes is need to be same. So here you can see the two attributes and here also the two attributes. And the order in which they are displayed, the data type should be same. So if this is int and this is varchar, this also need to be int and varchar, right?
Yes.
You cannot interchange this one. Okay, so these two are the condition for the union compatibility. So simply that means here the same,
Sir, what is the first condition?
which one? Union compatibility.
First condition. Yes, yes.
Union compatibility first condition is the number of attribute need to be same from both the expression. So first is the expression one, you can see A and B are the two numbers of attribute. That is the two numbers of attribute. From the E2 also there is the two numbers of attributes. That is the C and D. Numbers of attribute,
Yeah,
what?
yeah.
Yeah. And the second condition is the means data type of the attribute need to be same in or in the same order. If A is the int, then C need to be int. And if B is varchar, then D also need to be varchar. Yeah.
Yeah.
Yeah. Okay. So we can say this thing in this way. So this expression L1 union L2, this one first we performs display these things from here. So we kind of distributes the this theta joint over this L1 and L2. So we distributes the theta joint to this one. Okay. The next point is consider a join E1 theta join E2 and select L1. So no need to confuse the L1 and L2 is the set of attributes that is present in the select statement, right? So So these are the list of that attribute, right? So similar point, let L1 and L2 be the sets of attributes from the E1 and E2 respectively, and let L3 is the attributes of the E1, and that is the involved in the join condition theta, okay, but not in the L2, and L4 is L4 be the attribute, okay. So this L3 is the attribute from the E1, so that is not present in uh, this means both the expression, you can say in this way. So in the instructor tables, the which the name and the salary and the department's name, these are the unique, means that is present only on the instructor tables, not in the teachers table, right? So similar things in the teachers tables. So L4 is the attribute of the E2 that are involved in the joint condition theta, but not in the L1 union L1 union L2. So L4 is the, you can assume the year. Year is the only present in the teacher's table, right? Okay. So now we can see. So pi L1 union L2. So that is the means the expression that is present in both the tables. So this, you can say simple ID. So there is the only one unique. So you can whole thing you can assume as the ID is present on both the tables. So that is the ID, and the theta join is also. So this is the condition, and this is the whatever we want to display it. So this is present in the where condition, and this is present in the select. So similar things. So we can replace that things using this one also. So the attributes, that is the we want to, if so what this means. So suppose you want to select ID and the salary from this expression. E1 is the from instructor, right? This whole expression. So suppose this is the L1, this is the L2, L3, because that is not present in the L2, and this is the, you can select you can say ID, or not ID, you can assume another thing. So that is for here. So let me check. You can say semester. So you can say semester, right? Semester, and the next one is the year, okay, from teachers. So this whole expression is a denote as the T, and this whole expression is a denote as I, okay, or simply E1 as E1, and this is the E2. Then we need to perform the theta join. So this is the simple inner join. and put the condition E1. Okay, E1 dot ID equal to E2 dot ID. Right. So now what you want to display? So suppose this is the L1 and this is the L2. So you can simply here you can display select E1 dot ID and E2 dot semester. Right. You can replace this whole expression here also. That is the select. So whichever attribute you want. So I need L1. So I need to, here it is required from the whole expression. So first let me write select star from E1 is your instructor. Then join. I simply write in this way. Okay. Teachers. And this whole condition we can write inner join on E1 dot ID equal to E2 dot ID. Okay. Then from this whole expression, select star from instructor inner join teachers on E1 dot ID equal to E dot ID and whichever L1. So suppose you want to select from this whole expression. So suppose so this whole expression is a suppose E. So E1 dot ID comma E dot semester. Okay. So this whole thing is, so the whole thing is, if I summarize this whole thing, so we can write the whole expression like this. So you got how this is come, right? Okay. Now we see the set operation. So on the unions and the intersection are the commutative, right? So in the simple, that is the very simple. So E1 union equal to E1 union E2 equal to E2 union E1. So we can change, right, in this way. This doesn't make any difference. Okay. So similar thing, E1. Okay. So E1 union E2 equal to E2 union E1, we can write. So this is the union operation we can. So union is the commutative operation and there is the intersection, right? So intersection is also we can interchange in this way. E1 intersection E2 equal to E2 intersection E1. But in the set difference, we cannot write like this, right? We cannot write like this. So because, so suppose E1 expression is a consist of A, B, C, and the E2 is a consist of B, C, D. So can anyone tell what is the E minus E2?
A.
So that is A. And what is E minus? E2 minus E1.
D.
So that
Yes.
is D. Yeah. So because these two are not equal, so that is the difference. So that's why we cannot say the set difference is a commutative operation. Okay.
Yes.
So next we see the associative operation. So associative operation is the same. The set union and the intersection are the associative. So here you can see simple E1 union E2 union E3, then E1 union E2 union E3. So these two operation are the associative. So similar, the set difference is because we see saw a example. So that is set difference is, if set difference is not commutative, so yeah. So here you can see also we can check why. You can also check the why is the set difference is not associative. Okay.
Yeah.
Yeah. Next is uh, selection operation over the distribute over the union and intersection and the set difference. Okay. So let's see. Okay. So select theta E1 minus E1 minus E2. So minus means set difference. Okay. Equal to set these things we can write like this. Okay. So suppose you have to write the name of all the faculties that are from uh, name of the select name that is the okay. How to write this thing? Okay. Okay. Okay, I am giving the simple example, so ignore that one. So in the SQL query, so suppose 1, 2, 3, 4, 5, 6, 7, and the E2 is right. One, two, three, 4. Okay, and the I apply condition where the condition is where theta condition is where the numbers is, so suppose this attribute is n. So you can think about this is the one expression, or E1 is the relation and n is the attribute. E2 is the relation and n is the attribute. So I apply the condition where n is greater than equal to 2 and less than 4. Okay. So this is my condition. So here you can see E1 minus E2. So E1 minus E2 when I apply, so so this got cancelled. Okay. And 4 as well. So here I got the empty set. So yeah, that is so okay. Just ignore the theta part. So because I got the empty sets, that's why I want. Where the condition collect. Okay. Okay, let me write these things in this way. Okay. Where n is less than 10. Okay. This is our theta condition. Okay. Now what is your output? So now your output is the
5, 6, 7.
okay 5, 6, 7. This is the output from this expression. Now next one is the theta E1 against the same condition we apply, and that is the, and what is our output? N equal to the whole expression.
Yes.
So this condition returns E1 returns the whole expression 1, 2, 3, 4, 5, 6, 7. The next condition E2 returns the whole expression, that is the 1, 2, 3, 4. Okay. So if I apply here minus, so what we get? Against the same result.
Yes.
So in this way we can say this we can apply the similar thing here also. In place of you can replace and you can check it also for the union or the intersection for the also. So that's why we can say, so selection operation is distributed over the union, intersection, and the set difference. Okay. So here this condition we can apply all the condition. Similar thing. Similar, you can see the similar one expression is like this: E1 minus E2, and we can apply the theta join over the whole expression, right? But here you can see this, whatever the theta value, that condition or the attribute based upon we apply some condition, that is, that attribute is only from the E1, right? So if that kind of situation arise, then we can write like this, because the theta is the present theta or attribute we applied, want to apply some condition that is present in only E1s, then we can write like this. So similar, we can replace the union here, right? But not with intersection. We can replace with the intersection, because intersection is whatever. So this is the important, it's play an important role in during the intersection, right? But in the union operation, whatever's the attribute present here, right? So it also display. Okay, what I mean. Okay, let me write. Okay. So suppose you want the salary, not salary. So right now I am not coming with not not come up with any example for this one. So you can think like this also. So if this, whatever this expression, and we apply this condition with whole the expression, so this, okay, So the whatever the condition means, that is okay. Okay, just hello. Hello. Am I audible? Yeah.
Yes, Pradeep, you are audible.
So for the union operation, we also consider, we are discuss about this point, right? So, so this condition is only apply for the this minus operation, means set difference operation or the intersection, but it cannot apply for this one, because you can see during the intersection operations, we consider this is the play a major role in this intersection. Means if this is a large set of returns the large set of the data, and this is the less numbers of the data, then we consider only this one, means whichever the less numbers of returns the less numbers of data. But during the, if we applies the union here, so in the union is doesn't so it is during the union operations, so it is not play any major roles. So we, if this returns the 5 set and it returns the all the sets of the attributes, then it will not satisfy the condition, right? So yeah, because we take only the theta operation from this one, right? So yeah. So basically, in this operation is only work for the intersection and the set difference, but this is not work for the union operation. Okay. So the next point is the projection operation distribute over the union operation. So yeah, the point is correct. So union operation, suppose you have to find the name of the name of the instructor from the music department. So first you find the name of the instructor, where from music department. So that is department name equal to music, and you performs the union operation, right? Union select name from instructor where department name equal to this one, music, right? Not music, so this is physics. Okay, so here you can see this is the this operation, this is the L, and this is the whole expression. Okay, and this is the second one. So you can write this whole things here also. So we can out this thing, select a name, from the same things, the whole expression you can write the whole you can replace with unions. So it need to be union compatibility, that's why I am writing the name. So you can write the name, also salary you can write the same from this, from expression one, right? No need to confuse with the E1. So that is the instructor. Okay, so that is select name and the salary from the instructor, where department name music, then you performs the union. So that is the union. So here, so no need to confuse here. Similar thing you can repeat for the union. For the you need to be union compatibility. So salary from instructor, where department name equal to physics, right? As is supposed to. So here you can see this is the L1, select L1, and this is the whole is the E1 expression, and this whole is the E2 expression, right? And that is the similar to this one. So pi L E1 union pi L E2. Okay. So, and this is not in your syllabus, but if you want to find the from the group or the aggregation operations, what is the equivalence expression for that, so you can find out and explore it. Okay. Net next is the similar things whatever you have learned up to this. So I express explaining this pushing of the selection part. So here you can see this is the how we can push the selection operation. So this in here you can see the first E1 natural join E2, then we apply the condition. But here if this condition or the theta condition is has the only attribute from the E1, so suppose that this attribute on which we are applying the condition, so that is from the E1, right? So we can first filter out that records based upon that condition, and after that we can apply the natural join. In this way it will be cost optimized, right? So that is the pushing of the selection, right? And the second is the multiple transformation. So multiple transformation means simple. uh, Here you can see first we performs the natural joins between the E1 and E2. Okay, then we performs the with the E3 natural join with the E3. Similar things, we can also interchange that things. The first we performs the natural joins between E2 and E3, then we performs the natural join with the E1. So that is the difference. So you can check this example. Okay. Similar things, you can see these conditions. So this is the first expression. So phi, right? So initially what I explain. So this is the a projection of the select name and the titles from the instructor, teachers, and these tables. Our department name is music, and uh, year is 2009, right? So here you can see all the tables we first performs the natural join. So first perform natural join with teachers and courses, then performs natural join with instructor, and then we apply condition. And we can optimize these things by using the instructor, right? So first we filter out the only instructor we gets if we apply the condition in the department name equal to music, this condition, so we can filter out the instructor which the instructor from only from the music department, right? And in the teachers is also we can filter out by using year equal to 9. So then if we apply, then we have to perform the less numbers of the natural join, right? If we compare with this particular expression.
Yeah.
Yeah. So that's things we have to keep in mind. So this is also the pushing of the projection, that is the similar to this uh, that selection one. So yeah, similar to this one. So here the case is uh, this projection operation. So here you can see in the projection operation how we can push that. Yeah, you can go through this one, and if you have problems you can ask. Okay. And so we already see the joining orders of this. So join is this is natural join is the join associativity. So that is we already discussed about this one. First we can perform the natural join in the any order we like, right? So but here we can performs the natural joins. So this one, so suppose the R1 and R2, right? We need to keep in mind whichever's the less numbers of attribute. So here you can, sorry. So suppose this one is the 100 numbers of entry. Entry means record, and this is 200, and R3 have the 400, right? So if we perform this one, right? So then how many numbers of the join we have to perform? So if I multiplying that things, so you can think about that is the cost. Okay, simple. So that is the 200, right? So then we performs the natural join with the 400, right? Here. And here also the 100 multiply with the 200 into the 400. So here you can see the first we have to perform the natural join with the this many numbers of the attribute in this case, right? Then against with the that numbers of the attribute with, and then we performs the natural join with. So this is the more numbers of attributes, right? And so you have to perform the natural joins 2 times. So first with this, then it will increase the numbers of the records. Then we performs the attribute with natural join with this less numbers of attribute. So this is more numbers of records in the R3, right? Hence we performing the natural join 2 times, right? So that is increase our cost, right? But here you can see this is the less numbers of attribute compared to this one, and we performs the natural join with the 4, means whichever the large numbers of attribute with the 1 time. So in this way we can reduce our cost. The overall point is whichever the attributes we is with the more numbers of records, we trying to cross join or the performs the natural join with that one. We only try to perform the 1 times, not multiple times. Okay, so here you can see the point is so that one. So whichever's the more numbers of contains the more numbers of records, we keep outside. Means outside means we perform only 1 time natural join with that. Okay, I hope everyone got this point. Any doubt? Hello. Yeah. Okay, that is the joining order, how to decide the join order. So I think the next one is the only theory part, so you can go through that. So yeah, Subindu, you want to explain something?
So let me share my screen. Okay. So my screen is visible, right? Apple.
Yes, Subindu, visible.
So what is your doubt? I did not got it.
So what I was asking is, you explained nested loops join.
Yeah.
Where for record 1, outer,
Okay, let me join. This is outer table. Block 1, block 2 name. This is inner table. Let tag names block 3. And this is B4. Suppose there are 2 records, record 1 and record 2, each block. Record 3, record 4, record A, record B. Right. So
so my question is, what we learned yesterday, B1 will move, then B3 will move.
Yeah.
R1, RA and RB will happen as join.
Yes.
Right?
Yeah. First R1, RA, then R1, RB.
Yeah.
After that,
yeah. So that is my question over here.
Yeah.
Why it does not happen, or I mean, is there some concept that why it does not do R2, RA and RB?
So yeah.
Why B4 moves?
Okay. So in block nested loop join, what happened? This is nested loop join, right? And block nested loop join, what happened? First R1, RA.
Oh, okay. Because of algorithm. I see.
Yeah. R1 RB, then R2 RA. R2 RA in block nested loop join, it check condition is block wise. R2 RB, right? In block nested loop join. I have explained also block nested loop join. You can check. If you see
Yes.
the algorithm, this is the nested loop join algorithm. So you can see that for each tuple TR is the outer relation, R2 begin for each tuple TS. So basically for each tuple, we have to check all the, you can see that this is the inner relation. You have to check the satisfy the join condition or not. If they satisfy, add to the result. You can see that in block nested loop, in nested loop join. So is your doubt clear?
Yeah, I mean, this is the only way, right? But
Yeah.
given if we have to do some optimization, then this would not be the best way, right?
Yeah, so that we have learned block nested loop join. Yeah, I've also discussed block nested loop join. So let me discuss again block nested loop join. That will be better, right? So this is hard disk or secondary memory, and this is the main memory or buffer. So this, let's take this is outer table.
So Subhendu, what was that? What term will you use for that? That was nested loop. This is block nested loop.
Yeah, this is block nested loop because
And the previous was nested loop.
Yeah, because this is check the conditions in block wise. That's why it is block nested loop join. Okay, so you will got it. Let me explain once again. That will be better. Block 2. This, let's check. This is R1. This is R2. Record 3. Record 4. Right. And this is inner table. Then let's check this. Records are RA, RB, and RCRD. So what happened in block nested loop join? We'll discuss. This is the worst case memory ability. Worst case memory ability is only one block can fit into the main memory, right? Only one block, right? So R1, R2, and this is RA, RB. So what happened? First we'll check R1, RA. After the check R2, RB. First we'll check R1, RA, R1, RB record. After that, it will check R2, RA, then R2, RB. You can see that whatever the record present in block, it will satisfy the all. It will check the all the condition. You can see faster.
Fine. Yeah, right.
Okay. So after that, what will open after the completion of R2, RB? This block will be moved. RC, RD. Then we'll check R1, RC, R1, RD. After that, R2, RC, then R2, RD. After the completion of R2, RD, this block will move and this block will move. So I hope you got it.
Yeah, sure.
Okay.
Got it. Thank you.
Okay. Thanks. So if you have any doubt in week 12, you can ask. Otherwise, we can bind up the session.
Yeah, so hello. So this is the last session for week 12. So we have planned 2 revision session like on next Thursday. I think on 28th is revision session 1 and 4th of August is revision session 2. So in first session, that is revision session 1, we'll cover the concept from week 1 to 6. And in session 2, we'll cover the concept from week 7 to 12. Okay. So yeah, you can go through the first week 6 content, and if you have any doubt, you can note it down and you can ask in the revision session. Okay. So that will more be a doubt clearing session. We'll also prepare from our side, but it will be better if you ask your doubt in that session. Okay. So yeah.
Use for OPPE, the sessions that you held previously, specifically for OPP, that should be sufficient, right? I mean, or will there be some focus in the upcoming revision session also from OPP perspective?
No, that 2 sessions are sufficient, and we also released the mock test, right, on portal.
Yes.
Let's just go through those mock tests. Yeah, similar type of question will be there.
Okay.
Okay.
Okay. I think
Thank-
that's it. Yeah. Thank you. Thank you, everyone.
Thank you, everyone.
Thank you.